Alright, so moving on to word problems. And so here, well, first of all, notice how it says show all your work and draw a picture for every situation. And simplify to the simplest radical form, which means we don't want decimals. We want to leave it as a square root, a simplified square root of that. So let's start with number 14. It says find the diagonal of a square whose side is 9. So the first thing I'm going to draw is draw my square. Now I know my square is not perfect, but let's just pretend that it is. So what are some of the things I remember about a square? One is that all sides of a square are the same. So if they're telling me that one side is 9, that means all other sides are also 9. And we're actually looking for the diagonal. Remember, diagonal goes from one vertex to the opposite. Another property that we should remember from a square is the fact that it has 4 right corners and the diagonals are going to be bisected. But even then, let's pretend we didn't know. If we focus on the triangle that we have, or that we created here with a diagonal, you should realize that we have a right angle, which means it's a right triangle, and 2, we have 2 congruent sides. So it's an isosceles right triangle, which is telling you it's actually a 45, 45, 90. And so if it's a 45, 45, 90, just how we were doing above, we should label it as such. So the 2 sides are for x, and across 90 is going to be x square roots of 2. Now luckily here I have information for you pick and choose either side, which is telling me that my x value is 9. And so wherever I see an x, I replace it with 9. I already did that there, so the only thing that's left to do is replace this x with the 9 that's in front of my root 2, and I get the answer for the diagonal. The diagonal is equal to 9 square roots of 2. 15, sorry. So this time they're telling you we have an equilateral triangle. Okay, so before we even continue, I'm going to go ahead and draw my equilateral triangle. Now, as I'm drawing it, I'm trying to remember what are the properties that I know about an equilateral triangle. Well, an equilateral triangle means it has all sides that are the same and all angles that are the same. And so if all the angles are the same, and we have 3 angles, and we know that all angles for any triangle should add up to 180, that's telling me that each one is 60 degrees. Now let's keep going. And it says the perimeter, so remember, the way you find perimeter of any shape is you add up all the sides. And so they're telling me that the perimeter is 18. Well, and if I have 3 sides, I divide 18 by 3, and I get that each side measures 6 units. And they're asking us to find the altitude. Remember, altitude starts at the vertex, and it goes perpendicular to the opposite side. And so if it's perpendicular to the opposite side, it's going to bisect both the side and the angle. So this angle up here is being bisected. So let's think about it. If it's being bisected and it was originally 60 degrees, this angle up here is now 30 degrees. And this is the angle I'm talking about. And same with the side. If this entire side was 6 at the bottom and it's being bisected, which means it's now cut in half, that means this side is now 3. Which brings us to the next point. Notice the angle measurements. 30, 60, 90. So just how we've been doing, we're going to go ahead and label it according to 30, 60, 90. So across 30, we labeled it x. Across 90, we labeled it 2x. And across 60, we labeled it x square roots of 3. Now, here is a good thing that we have information for 2 sides, because I want to show you that we should get the same thing. Doesn't matter which side you choose. we set up the equation with what we labeled it. So we're going to use this bottom part down here. So we labeled that part x, they labeled it 3, and if we need to solve, we solve. In this case, we get x to be 3. Well, let's say, or let's pretend that we would have chosen this side, or we were only given information for that side. The same still applies. What we labeled it, set it equal to what they labeled it, and if you need to solve for x, solve for x. So here, divide by 2, and we get x to be 3, which is the same thing nonetheless. And so all that's left to do is go back and replace x with 3. And so because x is here in front of the square root of 3, when I replace x with 3, I get the altitude to be 3 square roots of 3 for my answer. Moving on to 16, it says find the length of the diagonal of a rectangle if the perimeter is 34 and its width is 5. Alright, so let's think about it. So first thing I'm going to do is draw my beautiful rectangle along with the diagonal. And I'm going to go ahead and label it. Now, before I label it, the only thing I know is that the width is 5. And so if that's 5, this opposite side over here is also 5. Since they're telling me that the perimeter was 34, remember, you find perimeter by adding up all the sides. So if I know 2 of the sides are 5 and 5, I'm going to subtract 10 from this 34, which gives me 24 left between the two lengths. And so remember, a rectangle has opposite sides that are parallel and congruent. So that 24 I'm going to divide into 2, which gives me the length of each side, which is 12. The next thing to remember is one of the special things about a rectangle is that it has 4 right angles. And so here they're asking for us to find the diagonal. Okay, so here's the diagonal. And if you notice, we have a right triangle. Now, if you're trying to use trig, you can't. And the reason you cannot is because you don't know what that measurement is. You don't know what that measurement is. And we cannot assume measurement, so you can't say, oh, it looks like 45 or it looks like such and such. No, we can't base it off it looks like. And so here, we can't use sine, tan, and cosine. And for the same reason that we don't know the angle measurements, we cannot use 30, 60, 90 or 45, 45, 90. Which brings us to one last option. The very, very first thing we ever talked about was Pythagorean theorem, where we have A, B, and the only important part was what we labeled C. C is always going to be the diagonal. And so here, the only thing I don't know is my C. And so if I have Pythagorean theorem, remember Pythagorean theorem is A squared plus B squared equals C squared. Now in this case, we're looking for C. And so C would be whatever A squared plus B squared, the square root of that. And so all I'm going to do is substitute in what I know. I know A is 5. I know B is 12. Put that in the calculator, simplify, and we get C to be 13. Or in this case, the diagonal is 13 units. 17. It says a ladder is 17 feet long. Okay, so that seems important. And the foot of the ladder, okay, so that the foot of the ladder means the bottom of the ladder. So if this is my ladder here, the foot means the bottom part, is placed 8 feet from the wall. Okay, so that already tells me kind of like a visual. So here's my wall, and here's the ladder leaning against the wall, and that's the distance. I would label it wall, and this ladder. And so I'm gonna go ahead and place or label it with what I know. It says the ladder is 17 feet long, so this entire length, the hypotenuse, is 17. And it says that the foot of the ladder is placed 8 feet from the wall, so this distance is 8 feet. And it wants to know how far up the wall does the ladder reach. So it wants to know this distance here. And so once again, we're not given any angle measurements. We don't know if it's a 35, we don't know if it's a 30, 60, 90. We don't know if it's a 45, 45, 90. So for that reason, once again, we cannot use trig. We cannot use sine, tan, cosine. We cannot use 30, 60, 90. We can't use 45, 45, 90. Which brings us back to using Pythagorean theorem. Once again, the only important part is what you label C. So here's my C. I can label that A, label that B. And so once again, we have A squared plus B squared equals C squared. Now this time we're looking for A. And so when I solve for A, I'm going to get whatever C squared minus B squared is. And so all I got to do is substitute in what I know. I know C is 17. I know B is 8. Put that in the calculator, and we get A, or in this case the wall height, to be 15. Now here they actually gave us what the units are, so we're going to put 15 feet. Moving on to 18. It says the legs of an isosceles triangle. Isosceles means two congruent sides, so I'm going to choose there. Are 16. And it says the base of the triangle is 24. Find the altitude. So I'm going to go ahead and draw my isosceles triangle with the sides being 16 inches. And the base of the triangle, so I'm going to do this, being 24. And it wants us to find the length of the altitude. So once again, the length of the altitude is going to go from the vertex to the base, perpendicular to the base. And so here, now, we don't really know any other information about any of the angles. So we can't assume 30, 60, 90 or any of that stuff. So once again, we're going to have to go back to your Pythagorean theorem. But before we do, however, we do know that an altitude is going to bisect, at least for an isosceles triangle, it's going to bisect the angle and bisect the side or the base. And so if the entire thing was 24, that means each one of these sides is now 12 and 12. And so this is the information I'm going to use to find the height of that triangle. And so I'm going to use Pythagorean theorem, labeling it A, B, and C. And so once again, just how we did the other one, the only thing I don't know is A, which is what I'm going to call the altitude. And so from here, A squared plus B squared equals C squared. I'm looking for A, so A is going to be whatever the square root of C squared minus B squared is. So if we put in the calculator, or actually, sorry, so we're going to replace what we know, so 16 squared minus 12 squared. And so here we actually end up with the square root of 112. Now, here we have a situation where it's not a perfect square root, and we don't want decimals. So we're going to have to simplify it, okay? And so what I recommend is making a little Christmas tree or a number tree with numbers that you know can multiply to 112. So two numbers that multiply to 112 are 4 and 28. So we kind of use that, so we don't need that no more. And I can further break down the 28. So what I'm doing here is I'm actually looking for number pairs. So I'm going to pause here because if you notice, I have a set of 4s. And so the way you can kind of think about this is every set or every two numbers inside the square root makes one of those numbers outside. And so because I have two 4s, a 4 comes out, and whatever does not have a pair, which in this case is a 7, is going to stay inside the square root. And so here's my value of a, or here's the altitude. So 4 square roots of 7 is the altitude. Now because it did give me units, I'm going to go ahead and include them in here. Inches. 19. Find the length of the diagonal of a rectangle if we know the perimeter is 28 and the width is 6. So just how we did the other one, first thing is we're going to draw your beautiful rectangle along with the diagonal. And if they're telling me that the width is 6, that means from the perimeter we're going to subtract 12, which gives us 16 units to work with. Now these 16 units we're going to split into two even parts, which gives me the length of my rectangle, which is 8. And so once again, remember, rectangles have right angles. And so I'm going to use this right triangle to solve for the diagonal, or C, with a squared, b squared, and c squared. And the reason I'm using a squared, b squared, c squared is because I do not know any angle measurements. And so once again, we're going to use Pythagorean. A squared plus b squared equals c squared. And in this case, I'm looking for c. So c is going to be whatever a squared plus b squared is. So all I got to do is replace or substitute a, which is 6, and b, which is 8. Put that in the calculator, and we get c, or the diagonal, to be 10.